Hello and welcome back. Now that we've learned what opportunity costs are, we can start learning how to apply marginal thinking or marginal analysis. In this video, I'll explain the concept of marginal cost as well as illustrate how to derive the marginal cost curve. By now you should have a fairly good understanding of opportunity costs and how to calculate them. The definition of marginal cost is very similar, except that when we talk about marginal costs, we automatically imply a specific and fixed increase in one good. The fixed increase we always apply is a 1 unit increase or a 1% increase. So essentially, the marginal cost of a good is defined as the opportunity cost of producing one more unit of that good. Let's go through an example. Let's assume there's a change in production from point C to point D in figure A, which is our PPF of our simple two-good economy. In order to calculate the marginal cost of an additional ton of wheat at point C, we need to measure the opportunity cost of this 1 unit increase in wheat production. This reallocation of production represents a fall in the output of power lines equal to 3 kilometers in order to produce the extra ton of wheat. Therefore, the marginal cost of an extra ton of wheat when the economy is producing 2 tons of wheat is 3 kilometers of power lines. Please take note, it is important to state which point we are referring to because marginal costs are not constant. Remember, marginal costs are the same as opportunity costs, except for the fact that they only ever represent a 1 unit increase in production of the good being referred to, in this case wheat. Because opportunity costs increase as we increase production, so do marginal costs. For every increase in the production of 1 unit of wheat or 1 ton of wheat, productive resources, which are ever more efficient at producing power lines, are shifted towards farming wheat. Thus the marginal cost as we produce more wheat increases, in line with the law of increasing opportunity costs. Since marginal costs are defined by a 1 unit increase along either the x-axis good or the y-axis good, it represents a rate of change. This rate of change is actually the same as the slope of the PPF line at any point. Therefore, if you can calculate the slope of a graph between each 1 unit interval for either good, you can calculate the marginal cost. Just be careful and make sure you understand which good you are referring as the cost. It is now time to draw our marginal cost graph using information derived from the PPF. Remember, the points on the PPF were provided to us. Usually in tests or examples, the points defining the PPF are provided in a table or they are already plotted on the graph for you. But now we're going to use our understanding of marginal costs to draw the marginal cost curve of our hypothetical two-good economy producing only power lines and wheat. You might be asking why we need to draw the marginal cost curve. In a moment or two, we'll use the curve to help us identify the most preferred combination of power lines and wheat for this economy. Remember, at this point, we can only identify all the production efficient allocations, but not the most preferred production efficient allocation yet. Before deriving the curve, always try to intuitively try and draw a graph first. Let's first think about what a marginal cost curve might tell us. If we were looking at a marginal cost curve, we would want to know the marginal cost at each point on the PPF. But because opportunity costs or marginal costs relate to a specific good, we'll only be able to plot the marginal cost of each point on the PPF for a specific good. So let's plot the x-axis first. Generally in economics, quantities always go on the x-axis, and because we want to illustrate the marginal cost of each successive increase in the amount of wheat produced, we plot the quantity of wheat along the x-axis. We then want to know the marginal cost in terms of kilometers of power lines for each point on the x-axis, so we plot kilometers of power lines on the y-axis and label this as marginal cost. Note, it's the marginal cost of producing more or less wheat, and therefore we call this the marginal cost of wheat graph. We now have the correct axis for our marginal cost curve, which we will call figure B, the marginal cost of wheat. All we need to do now is plot the various points by calculating the marginal cost between each corresponding point on the PPF. So let's calculate the first point. And be very careful, a lot of students get confused at this point. The confusion usually comes from forgetting that there are an infinite amount of points along the PPF, and thus to calculate all the 1% increases in wheat would take forever. So when we draw or derive the marginal cost curve from the PPF, we need to use averages so that the marginal cost curve is as accurate as possible. It would be impossible to calculate each individual marginal cost value for every milligram increase in wheat. Another way of understanding why we use averages is by looking at the slope of the curve. Remember, the slope of the PPF curve equals the marginal cost at that point. Because there are an infinite amount of points on the PPF, there are an infinite amount of different gradients because the PPF is not a straight line. So instead of calculating every single different gradient, we simply take the average slope between the points for which we have information, those being points A to F on the PPF. So let's use these points to plot our marginal cost curve. Looking at point A and B, we know that in order to produce the first ton of wheat, we eventually have to forego or give up the production of 1 kilometer of power lines. So between point A and point B on the PPF, we have to give up an average of 1 kilometers of power lines, or put differently, the average slope between point A and point B is 1. So on the marginal cost graph, we plot a 1 between 0 and 1 tons of wheat. Remember, we're using averages, so don't place a 1 above the 1 ton of wheat. Before learning bad habits, let's just remind ourselves what we're plotting. We're trying to graph or illustrate the marginal cost for each quantity of wheat on the x-axis. By plotting these marginal cost points, we'll be able to investigate how marginal costs might be changing over time. Now let's plot the marginal cost when moving from 1 ton of wheat to 2 tons of wheat production, or in other words, from allocation B to allocation C. Here we can see we have to sacrifice or forego the production of 2 kilometers of power lines. Now all we need to do is repeat the same calculation for each point on the PPF, and then join the dots to draw our final marginal cost curve. And there we go. Notice how the marginal cost curve slopes upwards. Does this make sense? A helpful tip when starting your economic studies is to always ask yourself why, or does this make sense? We already know and understand the law of increasing opportunity costs, and we know that marginal costs are just opportunity costs calculated for each 1 unit increase in production. So we should expect marginal costs to increase as production increases. We also know that the slope of the PPF equals to the marginal cost at that point. If we look at the PPF, we can see how the slope of the PPF becomes steeper as the production of wheat increases. And a steeper gradient implies that more power lines will have to be foregone in order to produce an extra ton of wheat. In other words, the marginal cost is increasing. From a theoretical point of view, we should also expect the marginal cost to increase, because as we increase the production of wheat, we're moving more and more efficient or productive resources away from producing power lines to producing more wheat. So if we had to plot the marginal cost curve for power lines, what do you think the graph would look like? Do you think it would look the same as the marginal cost curve for wheat, or do you think it would be the inverse and decreasing? It must look the same in terms of direction, or in other words, it must be increasing. The actual marginal cost values, now in terms of wheat foregone, might be different, but the graph must be increasing. The same law of increasing opportunity cost applies to all goods being produced in an economy, whether they're on the y-axis or x-axis. The only difference will be in the values in the label.